So what is artificial intelligence? Well, it is when scientists try to make machines perform human-like processes, and hopefully in the future machines will use AI to become human. There are three types of AI. Reactive machines, which are the simplest form of AI. They do simple jobs such as lights that turn on when someone is in the room. Limited memory AI, which is what we are currently designing and improving. These include self-driving cars, in which automatic cars are shown many different videos to teach them what to do. However, their memory is not evolving, so basically, it doesn't create new memories and actions. Self-awareness is the final type of AI. It is a future form in which machines will be able to act and react like human beings. Now, there are many different uses of AI. There's virtual personal assistants, smart cars, face recognition, web series predictions, sports predictions, and medical forecasting and diagnoses, among a multitude of others. So let's dive into a case study that was done to predict whether or not a patient will have diabetes. I used Anaconda Jupyter Notebook to run all the commands for this study. I won't get into much detail about the Python commands, but if you want more information, the link to a more professional video on this case study will be down below. First, we will use past data, such as whether or not people that are pregnant have a high risk of diabetes, and other factors such as glucose concentration, blood pressure, age, insulin level, and whether the patient actually had diabetes or not. So basically, these three lines of code will take the data CSV file, read it, and then display the first 5 lines with neat organization. In simpler terms, the code above just focuses on 7 of the columns and normalizes the data so that all the values in the data will be relative to each other and the results won't be skewed. For example, the numbers under glucose concentration are higher than the numbers under insulin, so we want to make sure that all the values will come out as between 0 and 1 so that the results will not emphasize glucose concentration over insulin. Then the numerical data is mapped into neat columns using TensorFlow, which is a free software. These lines of code take the column groups and converts the letters to numbers and creates a histogram. These lines put all the data together and make sure that there are only 2 results, either the patient has diabetes or not. The final line of code actually trains the model. Next, the model needs to be tested for accuracy. So the first 5 lines are one output. Earlier, classes was set as the answer, so on the 5th line, by classes, it says B'1'. The B means that the answer is in binary, so either 0 or 1. The 1 means that the patient has diabetes. The prediction then must be evaluated, and the accuracy is approximately 72% accurate. Another fascinating project done regarding predicting is IBM Watson. IBM Watson teamed up with ESPN Fantasy Football to help people better predict which players and teams will play better. Similarly to how in the diabetes case study, a dataset was read, IBM Watson is a machine that is given thousands of articles, datasets, and videos to view. A massive amount of the text from historical fantasy football seasons and football websites and definitions were used to create a merge of 2 vector models in which words were converted into number representatives. The vector ensemble model was outstandingly accurate with a 97.96% accuracy. IBM Watson is obviously much more complicated than the diabetes test, as there are multiple deep neural networks and models used to predict if a player would boom, bust, receive an injury, play with an injury, and if they would carry out valuable minutes. All of these models scaled the end results so that they would all be relative to each other and have the same threshold. However, the accuracy of these models were on average about 67%, with the most accurate one being the valuable minutes model at 82%, and the least accurate model being the bust model at 57% accuracy. There was another model made that connected these models to individual players, so that there would be a percentage shown of the likeliness a player would be to boom or bust. Finally, the last model was made to take multiple outputs and convert them into official point scores for each player. These scores are displayed on a player card. Players can also be compared. In the graph, you can see that player 1 is more likely to score better than player 2. There is also a news trend tab, which shows that the players are in a positive, neutral, or negative light in regards to the media. Using IBM Watson, trial tests have shown to have undefeated scores during the ESPN fantasy football season. Another sport-related study done with IBM Watson is when they teamed up with AELTC to bring viewers and ticket holders a better and more engaging experience in the 2017 Wimbledon Games. The Watson Discovery Service took 22 years of tennis data, and during the game it was used to start debates over social media. Similarly, Watson's Personality Insights API also gathers information to stimulate conversation, but this time the information is focused on players' characteristics found in interviews. IBM Watson also created Ask Fred, which is a voice-activated online assistant that answers questions about dining nearby, transportation nearby, and locations of areas in the venue. Wimbledon IBM Slam Tracker produces real-time statistics and information, so people in the crowd can see certain players' scores and tactics before a match.